Everybody, it's Lee from VR Dev School. We're here at Immerse in Bellevue, and I'm here with Robert, a good friend of mine from CognitiveVR. And Cognitive has this really awesome analytics platform for VR developers, so I've definitely seen it before, and we've been using it. It's really great, so I wanted to get him on videotape here and get Robert to take you guys through some of the things that they're working on that I think would be really useful for all VR developers. So Robert, why don't you go ahead and start giving us showing us what you've got.
Yeah, so one of the big problems and benefits of virtual reality is the agency of a user in that virtual world, right? So you can't direct them, you can't force them to do anything. That defeats the whole purpose of virtual reality, right? So right away, you have all these problems where you throw people into VR and you have no idea if they actually did what you wanted them to do. In a traditional medium, that's okay, because you can just move the camera and you're good to go. In VR, you can't do that. You have to make sure that you build your world appropriately so that they do exactly what you want them to do, and they experience your narrative or game or training simulation in the way you want them to experience it. So what we've built here is a visualization tool called Scene Explorer, and this lets you scroll through user sessions in virtual reality. So this is me a few moments ago recording and sending it to our server, our dashboard. And as you're beta testing your game or looking for bugs or seeing if your early users like what you built, you can implement this and then you can see exactly how a typical user might jump through your level. Did they kind of ignore a big narrative piece? Did they encounter bugs? Did they leave you bad Steam reviews? Okay, let's see what they did. Oh, it turns out they completely missed out the point of the game, right? So we help you answer those questions and figure out how to diagnose issues with your VR experience.
Yeah, so you've got somebody like you've got some point in like a level maybe you see where everyone's kind of dropping off, you're losing users, and you wonder why, because I've definitely had that in a bunch of games where I'm not really sure what's the next step, and depending on some of the VR experiences, like so far it's been kind of hard to make sure that the user's attention is directed in the way that you need to be. So maybe it's a voice command that says, oh, this is the next thing you have to do, and people miss it. Or if it's pop-up text, they're almost certainly going to miss it,
Exactly.
So this would be really nice in a way to go back and say, oh, what is the thing I made an assumption as a developer that would be easy to follow. Apparently that's not the case, but I need to know exactly where people are falling off, and this gives me a chance to figure that out, right?
That's exactly right, yes.
Yeah, that's awesome, yeah.
So, if you're a developer, you're building games, or you're building any type of experience in VR, a lot of people are on project number 2. They built their first demo, they loved it, but they want to know the ROI, they want to know how many people used it, how people used it,
right.
And you're exactly right, that they follow the narrative that you wanted them to see.
Yeah, exactly. So what about performance? I know you guys have a bunch of stuff here that also helps with finding performance issues, like if I want to figure out what scenes in my game or what objects in my scene even are causing issues. So how do you guys deal with that?
Yeah, that's exactly right. So while you're running your game, ideally you're running at 90 frames per second. You get that silky smooth, buttery VR experience. But sometimes, especially in VR, you have no idea that performance issues are happening. Again, these could be just random forum reviews on the internet. You don't see them.
Yeah.
So what we've done is built an automatic profiler that runs through at runtime on every user, and you can see just what their frame rates were. Did they have really bad frame rate issues in certain areas, and what caused those frame rate issues? Were they in certain spots that had unoptimized textures or meshes? And you can also kind of correlate that to different graphics cards or processors and see if maybe there's some bug with some certain graphics card, and instead of spending upwards of 50% of your time debugging performance like some of our customers have done, you reduce that time and you start building games instead and stop worrying about performance issues.
So it's definitely something like on N-Space, we haven't had a whole lot of performance issues there, but it would be something that's really nice to figure out, you get a review or some comments from somebody there, and sometimes you don't really have a lot of information about the devices that they were using or where they had the issue. So it'd be really nice to be able to replay a session or try to get more information that would help me figure out where someone's having a problem that I can resolve that issue.
That's an ideal use case for us, right? Again, we've had people spend days and days and days tracking down a bug, and it turns out it's a texture in some corner of some level that they spent a week or hundreds and hundreds of developer hours searching for. So if you can cut that down to 0, or maybe not 0, but cut the searching time down to 0, you as a developer can then make a better VR experience.
Right.
That's our mission.
Focus on that, So how does that work then? So you guys have a dashboard, right?
That's correct.
You want to go, how does a VR developer then go from realizing there's a problem, or how do they interact with your software to figure that out?
Sure, yeah. So what you do is you implement our SDK. We have 3 core features. We have the analytics dashboard, we have Scene Explorer, and we have something new called Exit Pull that we're releasing this month. So what you do is you put in our SDK, API key, click save, click export, good to go. And then when someone has a problem, you can see that on our dashboard. It'll say, right, performance issue, performance issue, performance issue.
Right. Okay.
And then you can start drilling down to see what were those performance issues. Was it a FPS issue? Was it something to do with your processor maybe? And then you can cross-section that in the hardware. And then you can go and check, which user sessions did these performance issues belong to. And then you will jump to a screen that looks very similar to this.
Right.
And then you can see right visually on the map where those, red exclamation mark performance issues happen. This is where 90 FPS was not achieved.
It's literally a red exclamation mark.
It is literally a red exclamation mark, yes.
In 3D space.
In 3D space.
Yeah,
so
that's great. Yeah.
Our Scene Explorer technology works by exporting your level from Unity or Unreal Engine. It's fully working on a web browser, so you can see this is a 3D scene. I'm on Google Chrome right now. And we let you just, you have some marketing or developer implications. You don't have to open up Unity. You don't have to look at your source code to see that.
Right. Yeah.
It's just all on the web.
You have your QA team looking at those kind of things, bring that back to the developers.
That's correct.
Yeah, that's great. So how long does it take to implement the SDK in, let's say, Unity?
The base level install takes a couple minutes, 5 minutes, let's say.
Okay.
And that's, download the package, click start, put your API key in. Once you start adding custom events, user picked up Coca-Cola can or user made purchase, you have to add those lines of code, it's very straightforward.
Okay, pretty simple there.
Yeah.
Okay, yeah. What about performance considerations? Is there any kind of do I have to be worried about how many events I can be sending, or do I have to worry about anything like that?
So we've extensively tested this. We've tried sending multiple events per millisecond, and it's been okay. Obviously, that's crazy. We don't do that.
Yeah, right.
But it's been very fine on anything from Cardboard to Gear VR to Vive to Rift to anything in between. And we don't use raycasting. I know a lot of people have been concerned that if they're already raycasting something, do not use raycasting, just to throw that out there.
Okay. So you're not worried about performance.
Yeah, we have much more optimized.
The data packets themselves are quite small. There's not a lot of bandwidth.
They're small. They're akin to some server calls you might make in a multiplayer game.
Okay, so it's very small data packets.
That's correct.
What about obviously this requires a user to be online. How do you deal with some users might be connected, some users might not be connected?
Yeah, if you're in an offline scenario, we simply fail silently. We can't find the server, nothing happens, you keep playing your game.
Okay.
If you are connected, things work beautifully, it's all silent.
Okay, yeah, so no worries there. I don't have to worry whether or not they're connected, it's going to work
exactly.
Anyway. Yeah, either way it's okay. Yeah, cool, well that's great. So that's CognitiveVR's analytics platform. You guys are at CognitiveVR.co.
That's correct.
Yeah, I'll definitely put a link below the video to their website. You can easily download the Unity package to get started. I've been playing with it too. It's been fantastic. We're in Vancouver together, so we see each other all the time and talk about what great ideas these guys are working on. It's been fantastic. So thank you very much, Robert.
Yeah, thanks for having me. Yeah.
Check it out, everybody. You're gonna love it.